Hello students, today we are discussing another topic of the same chapter, that is some basic concepts of chemistry. In continuation with that, today we are discussing few more topics. See, in the previous session I discussed matter and its classification, laws of chemical combinations. Now I am discussing the more important topic of the same chapter, that is accuracy, precision, units, fundamental units and derived units, Dalton's atomic theory and atomic mass number, calculation of relative atomic mass. Okay. So first, let us start with accuracy and precision. We are discussing definition later. Okay. You take a small example, then you will come to know the exact meaning of accuracy and precision. For example, you are doing one experiment, okay, in the chemistry lab or in the physics lab. You are conducting the experiment, you should show the result to the teacher, then they will confirm whether your result is correct or not. How it is possible? Sometime what they do, if you approach to the teacher, they inform you to perform it again. Sometime your answer is correct. How it is determined? What is the reason behind the correct answer and repetition of the experiment? Let us take a small example. So usually in the chemistry lab we have titration. Titration is used to perform to determine the strength of unknown solution. Acid and base is given to you. So the strength of base may be known. You are calculating the strength of an acid using the standard base. You will be performing an experiment. Okay. So you are informed to do the experiment thrice. What is the purpose? Let me explain. See, person or a student A performs an experiment. In the trial 1, he got the value 18.6 ml, milliliter. Okay. Even you don't know whether the answer is correct or not. Second trial will be conducted by following the same procedure. Just observe the result. He got 18.7 ml answer. Then if you observe these values carefully, it's almost same. Almost same. What it indicates? So it clearly indicates, being the values are almost near, the value should be either first or second. Either first or second. No means there is no confidence whether it is a first or second. The reason it is 0.6 and 0.7. So to make it confirm, one more trial will be conducted. One more trial will be conducted. Just observe, it is 19.3 ml. 19.3 ml. Same experiment, same person, under same condition, the experiment was conducted, but the values or results are different for trial 1, trial 2, trial 3. Now, just observe, the value is 19.3. This value is not matching either with first or second. Now we are under confusion, or a student who performed that experiment is under confusion. Whether first is correct, second is correct, or third is correct, you don't know. If you consider first, By considering the second value, it is appropriate, means almost same. You may take average, and average of 2 may be given. It may be correct or not. Why he is under confusion? He got the third value totally different from the first and second. So this accuracy and precision is applicable here. So what exactly the meaning of accuracy and precision? Fine. The student approaches a teacher giving the value 18.6 ml. 18.6 ml. What they say? Okay, fine. This value may be correct. Okay, they will tell this is correct. This is correct. But it is not accurate. It is not accurate. Why? On what basis the word accurate is used there? The reason, see, before giving you, the experiment was conducted and we have a set of value. So that value should match with the person who performs in the laboratory. So the value with the teacher is 18.5. 18.5 should get. But the student got 18.6. Why it is considered? The reason, this value is near to this. Just 0.1 difference is there. It can be considerable. But it is not 100% accurate. The reason 18.6 is not equal to 18.5. So accurate value should be 18.5. Then these two values, 18.6 and 18.7 ml, is said to be the precision value. Why? Means these two values, whatever the experiment was conducted by a student, is getting almost the same value, which is matching with the accurate value. These two values are considered to be precision because first and second values are almost the same with a small changes or with a small error. This 1 and 2 is considered to be precision value. 1 and 3. What is the relation between 1 and 3? This is also a value. So, but 1 and 3 is not considered to be precision because there is a difference in the value. One is 18.6, another is 19.3. It is not appropriate. See, this is not matching together. Even second and third also. So first and second is considered to be a precision values. 18.5, it is an expected value. It is considered to be accurate. 18.6, whatever the student is represented to the teacher, it is also matching with 18.5. So 18.6 and 18.5 both are precision, but the expected value should be 18.5. Why should we scratch over it just 0.1, 0.2, 0.3? The reason, during the experiment, every value, every digit is considerable. So it might be a small, it might be a big difference. It may not equal or it may not match with the accurate value what we are expecting. So now with this example, let us discuss what is the definition for accuracy, what is the definition for precision. First one is accuracy. The accuracy is the degree of closeness or agreement to the standard value is given by accuracy. So accuracy means 18.5. This is an accurate value. We should get the same value. How it was obtained? This was also obtained by conducting the series of experiment. So this value directly depends on the precision. So more closer the values, more the precision values, and the accuracy will be uh, authentic. Otherwise, it is unauthentic. So the degree of closeness or agreement to the standard value is given by accuracy. Given by accuracy. Then what is the meaning of precision? In a set, a precision gives us the degree of deviation from each other. Just look into this 1 and 2. This both the values are almost same with respect to each other, but it is not equal. The reason it is 0.6, another is 0.7. Both are close together. 1 and 3 is not considered to be a precision, the value is totally different. Accuracy is related to closeness to the standard value. So, whatever I said, the example standard value should be 18.5. 18.5. This accuracy means if you produce 18.6 ml, okay, it is very close to this accurate value, it can be considered. Suppose if you present 19.3 ml value, they won't accept. Why? This value is not close to the expected value. The experiment, whatever is conducted, is not correct. Hence, this is not considered to be accurate. Not considered to be accurate. So, this is how accuracy and precision is differentiated. We are usually applying the concept of accuracy and precision in laboratory during the representation or presenting our results. Just think, you only perform the experiment, reagents are same, conditions are same, why you got different values? What might be the reason? There are many reasons for getting different results for different experiment. The first reason may be due to manual error. Manual error in the sense how you are handling the reagent. In some cases, some reagents might be added in excess or it may be added in less quantity. That might be the condition. And whatever the physical conditions to be maintained, there is a temperature, pressure, incubation. If you miss or skip any one of these parameters, it leads to different results. These are all considered to be manual error. Manual error in the sense, whatever the experiment is conducting by a person, because of his negligence, it happened. Hence, it is a manual error. That is one. Second one is instrumental error. Instrumental error, usually we are using electronic instruments which depends on different parameters. This error occurred due to any mistake or any problem associated with the instrument. Voltage fluctuation might be the reason, and the frequency of light set for the estimation might be changed. So that might be the reason. This is considered to be technical error or instrumental error. So because of both the errors, we are getting wrong answers, which is said to be non-precision. If the precision is not there for your experiment, it is difficult to get the accurate value. The accuracy can be determined for a particular experiment with the help of precision value. So this is how we are differentiating accuracy and precision. This is a separate topic, but it is applicable for laboratory. Okay. Next we are discussing another important topic of this chapter, that is units and physical quantity. Before all these things, let me discuss what is the importance of physical quantity and its unit. Take an example. You are going to a grocery shop. You are supposed to buy a rice. How do you ask a rice? Do you ask this much rice? This much? No. You are asking, give 1 kg of rice. Why you are using the kg? Because that quantity is expressed in terms of kgs. That is a mass. Mass you are expressing in terms of a kg. So you are asking 1 kg of a rice, 2 kg of a rice. In the same way, you are taking groundnut oil or coconut oil. You won't ask this much oil or this much oil. You are asking in the terms of 1 liter, 2 liters. See, here 1 and 2, these are the numbers you are using for both mass as well as volume. Mass as well as volume. But what is the difference in both the case? In the first case, you asked 1 kg. Kg means it is known you are expressing a physical quantity in terms of kg. It indicates it's a mass. So in the second case, the quantity you are expressing in terms of a volume, 1 liter, 1, 2, 3, 4, these are numbers. So these numbers are associated with the units. These units represent represent the physical or quantities, or physical quantities are represented through the units. So this is the significance of the units. That's one example. In the same way, how we are measuring? Suppose if I ask you, what is the length? You won't say 5. 5 means it is a mere number. It is a meaningless. 5 means, again I will ask, what is 5? It is a kg? No. It is a gram? No. Liter? No. You may tell it is a 5 inches, 13 centimeter, 6 centimeter. That centimeter, kgs, length, you are expressing the length in terms of meter and centimeter. These terms are considered to be units. They are said to be units. Okay. So these are some of the applications or importance of units. Without units, it is difficult to represent the physical quantities just with the help of numbers. These units are classified into two types. One is fundamental units or basic units. What is the meaning of fundamental? Just look into the name itself. Fundamental means these are the basic units. These are the basic units. It does not depends on other units to express it. Hence, it is said to be a fundamental or basic unit. We have 7 fundamental or basic units. The first one is mass. Mass is symbolically represented as m, and it is expressed in terms of kilogram, and symbol is kg. You may ask, why sir it is to be a kg? Why not in nanograms, grams? The reason, again we have different methods to express. One is SI system of expression, CGS system of expression. So in the research or in the science, to overcome the confusion, we are following a standard international unit, that is SI system. It is not mean that other systems should not be used. We can use, but it is a standard system to be followed. So whatever I am discussing, it is with respect to SI system or standard system. Okay. So first one is a mass. Mass is symbolically represented as small letter m. So here representation is important. For a particular quantity, a symbol is fixed m. If you use capital letter M, it represents some other physical quantity. Therefore, symbols are very important. How this is represented as a unit? It is kilogram, kg. K should be small, G should be a small. If you write capital letter K, it is the representation for Kelvin. and if it is just capital letter G, it's a gravity. Therefore, it should be a small letter K and small letter G. Another is length. Length is represented as L, small letter L. It is meter, it is in SI system, meter. Small letter M is the unit for length. Time is another fundamental quantity. It is represented as small letter T. Its unit is second and the symbol is small letter S. Symbol is small letter S. Fourth fundamental unit is current. Current is symbolically represented as capital letter I. Its unit is ampere and a symbol for ampere is capital letter A. This is for current. The temperature is represented as T, that is capital letters T. See, here we have a T for a time, but it is a small t, capital letter T for temperature. That's why we should be very much careful while representing the quantities. If you make any mistake with respect to the symbol, it represents some other physical quantities. So these physical quantities or the symbols are very helpful during calculation. So they may not ask what is to be calculated. With the help of a units, you should know what is to be done and derivation should be made. So that's why these fundamental quantities and the derived units, everything should be known clearly. Okay. Temperature, it is capital letter T, represented as Kelvin. Its symbol is capital letter K. Capital letter K. This is very important. Temperature and amount of substance. Amount of substance. Usually in the chemistry, amount of substance is expressed in terms of mole. This is represented, amount of substance means small letter n. Its unit is mole. Symbol for unit is mol. For example, 5 moles of oxygen O2. I am not telling 5 kgs, 5 gram, 5 liter. Instead, I am using a word 5 moles. 5 moles means it is not just a 5 atoms, 5 molecule. We have a calculation for this. So to get a 5 moles, how much grams of oxygen or how much kgs of oxygen, how much liters of oxygen should be taken. So this mole concept is very important. Mole is nothing but it is a SI unit for amount of substance. Next is luminous intensity. Luminance intensity is IV. It is represented as candela. It is CD. These are all the 7 fundamental units. So first one is mass, second one is length, third is time, followed by current, temperature, amount of substance and luminous intensity. And these are the symbols for its unit: kg, m, small letter s, capital letter A, capital letter K, mol and cd. I think it is clear about fundamental quantities and SI system. Now we are discussing derived units. What is the meaning of derived units? Any idea? Yes, just look into the definition or name itself. It states it is derived. So derived means it is depending on other to express its physical quantity. They are said to be derived units. Derived units are obtained by the fundamental units. fundamental units. For example, take area. What is the meaning of area? See, area is written. If you observe the unit, it is given meter square. Meter square is a unit, not meter, it is a meter square. What do you find? Area is equal to length into breadth. What is a length? It is a measurement. How length is measured in SI system? It is in meter. Then breadth is also a measurement. It is to be written m. Meter into meter, it is meter square. This meter square is a unit for an area which consists of the two fundamental units. That is meter only. Meter into meter, it is a meter square. It is derived from fundamental, hence it is called derived unit. Derived unit. Take one more example. Volume is given. Volume. Volume is a physical quantity. What is the definition of a volume? Volume is nothing but length into breadth into height. Length into breadth into height. Now, length is a measurement. In SI system, it is a meter. Breadth is in terms of a meter. And height in terms of a meter. So, if you multiply all, you got meter cube. It is also called cubic meter. Meter cube or cubic meter is derived from meter. Meter into meter. Hence, m cube or meter cube is a derived unit. It is a derived unit. In the same way, you take density. Take density. See, density is nothing but mass by volume. Mass by volume. Look into here. How mass is represented? Mass is represented in terms of kg, SI system, kg. Volume, already it is discussed, it is meter cube. Now, what should be the unit for a density? It is kg per meter cube. Kg per meter cube. Kg meter minus 3. It is the unit. Now, you have two fundamental units here. One is kilogram, another is meter. Density unit is kg per meter cube. It is a derived unit because it is associated with fundamental units. This is how the units are classified into fundamental units and derived units. So, what we studied? The two topics. One is accuracy and precision. Second one is units, that is the derived units and fundamental units. Now we are discussing another topic of this chapter, Dalton's atomic theory. See, what is the meaning of theory? Theory means it is just a presentation. So, it may be correct, may not be correct. So, this might be obtained through theoretical data. There might be no scientific support to prove it. This theory should be proved scientifically. It might be correct, may not be correct. Hence, it is said to be a theory. It's just proposal. So Dalton's put forward a theory. It is said to be Dalton's atomic theory. So if you recall the definition for a matter is made up of elements. It is nothing but elements. Elements are nothing but it is made up of a similar type of atom. If you take a particular element, that element is made up of a same type of atom, hence it is said to be an element. So the concept of atom was given by Dalton. He states that all matter is made up of a indivisible particles called atoms. What is the meaning of indivisible? So according to him, whatever the components present in the matter which are nothing but atom which cannot be further splitted. We cannot split further. We cannot break it further. That particle is considered to be an atom. First one. See, all atoms of a given elements are identical in mass and properties. So this looks very simple. It has great importance for further development of science or chemistry by taking all these theories. Look here, second point, all atoms of a given element are identical in mass and properties. You take chlorine element and oxygen element. Chlorine element and oxygen element. Okay. See, you are telling a chlorine, you are telling oxygen. Why you are telling a chlorine and oxygen? Because chlorine and oxygen does not show same property. Both are gases. Chlorine is also gas, oxygen is also gas, but it does not show same physical and chemical properties. But we are telling chlorine is also made up of same type of atoms, hence it is an element. Oxygen is made up of oxygen atoms, hence it is an element. But this is chlorine, this is oxygen. Why? It shows difference in the property. The difference in the property between chlorine and oxygen element is due to difference in structure of atom. Both are atoms, no doubt, but structure of atom of a chlorine is not same as structure of atom of oxygen. Whatever the chlorine atoms you take, they are identical. You take a chlorine atom from different source, NaCl, KCl, HCl. Chlorine means structure of that chlorine atom is fixed. Structure in the sense how? It will be explained further. Wait. Now it is clear. So all atoms of a given elements are identical in mass and property. So the mass and properties of chlorine atom is same. No changes. See, whatever the atom I am representing, it is same with this. This is also same. This. It is not different. All these atoms are identical with respect to its mass and properties. You take oxygen atom, all the atoms of oxygen are identical with respect to mass and properties. Hence, the property of an element is depending on the structure of an atom. Hence, atom is a fundamental unit of an element. The property of an element is decided by an atom. Very simple example. So you are all the first year student. So no doubt all the students in the classroom is considered to be first year. Even though you are the first year student, are you identical with each other? No. We are all human beings. But we differ each other with respect to many aspects. But we are all considered to be human beings. In the human beings, we have some differences due to complex, due to language, due to activities. So in many aspects we are differ each other. That is an personal identity. In the same way, chlorine element, oxygen element may contain atom. The atom of chlorine is not same as the atom of oxygen. It differs due to difference in the structure. It shows different properties. This is very much required. This is only one sentence. It has a great meaning and significance. We should learn that. Look into third point. The atoms of a given elements are differ from those of any other element. Already I discussed. The element, you take a chlorine, oxygen, the atom of a chlorine and the atom of oxygen is not same. It is not identical. They differ each other with respect to its structure. As a result, the elements shows difference in property with respect to the other elements. Okay, fine. Let us take a small example to explain this. If I ask you, give an example for metal. You will tell gold, iron, silver. See, gold is also metal, iron is also metal, silver is also metal. But we use gold and silver for preparing ornaments. We are not using iron. Iron is a metal. Why we are not using iron to prepare ornaments? We are using iron for construction or a civil work, not gold and silver. What is the reason? In spite all are metals. Just observe carefully. Iron, gold, silver, all are metals, no doubt. It shows some properties, identical malleability and ductility that can be seen. The property of a gold metal is not same as the property of iron metal. Simple example, iron undergoes a process called rusting. Rusting means it loses its property. It converts into its respective oxide. That process is called rusting or a corrosion. Hence, this iron is not used for the preparation of the ornament. Take a gold, you put gold in water for 10 years, 100 years, it remains as such without undergoing any changes. Hence, it is used in the preparation of ornaments. Even though both are metal, the properties are different. That difference in the property is due to difference in atomic structure. Therefore, chemical and physical property of an element is decided by structure of an atom. The atoms of two different elements are non-identical. This non-identical property or non-identicalness is responsible for different properties. This is a third point. Okay. Look into fourth point. See, in the yesterday's class, we discussed about the compounds. Compounds are purest form of a matter. It is made up of two or more non-identical or different elements which are combined together to give the compounds. He has proposed how these compounds are formed. Compounds are the combination of two or more different types of atom. So when different types of atom which combines together, it gives compound. Example, hydrogen plus oxygen, it gives water. Carbon plus oxygen to give carbon dioxide. Hydrogen is one element, oxygen is another element, it gives water. Carbon one element, oxygen element, carbon dioxide is a compound. These compounds are formed by the combination of different atoms of the element. This is the fourth point given by Dalton's atomic theory. The next one is a chemical reaction is rearrangement of atom. What is the meaning of a rearrangement atom? So, during the formation of a compound, the atoms are involved. When these atoms are involved in the formation of a compound, it does not take place by a simple way. Accordingly, the chemical reaction is a rearrangement of atom. When it combines, one atom combines with another atom, it loses its identity. Loses its identity means, take an example, hydrogen and oxygen here. When hydrogen is in the purest form, it is a fuel. Fuel means it catches a fire and it gives energy during the combustion. Oxygen is a supporter of a combustion. It is must for burning process. This is different. Hydrogen in its pure form, oxygen in its pure form, it shows a different property. When these two combine to give water, the water which is a compound obtained from these two, this exhibit difference in the properties. So difference in the property. Why? What made to show difference in the property? During this chemical reaction, rearrangement of atoms takes place. As a result of rearrangement, we got the product, that is a compound. It shows difference in the property which is not the same as the reactant which was involved in the reaction. This is the exact meaning of the last theory. That is a chemical reaction is a rearrangement of atoms. So these are some of the theories proposed by Dalton under a heading Dalton's atomic theory. Now we are discussing applicative part of Dalton's atomic theory. Now onwards, actual chemistry will be learning. So as I said in the previous class, you should be familiar with at least 30 different elements, 1 to 30, its symbol, atomic number as well as mass number. Then it will be easy. Now let us discuss the topic atomic mass, atomic number and symbols. Actually, the representation of an atom you will be learning in the chapter structure of atom. But you should know at least preliminary concept about structure of atom and its representation for numerical purpose. Look here. Take any atom. Example, hydrogen. Hydrogen is symbolically written as H. This is the first element in the periodic table. We are using H1 like this. H1, 1. Okay. What is this? What this number represents? Simply if I write H, it's a symbol, no doubt. But if I write H11, there should be some meaning and importance. What is that? See, this is said to be superscript, which is right side top of a symbol. Right side top of a symbol. This represent mass number. This represent mass number. This is subscript left to the bottom of the symbol, which is nothing but atomic number. Atomic number and mass number is represented symbolically. For example, AZ. A represent mass number, this represent atomic number. So I have given 30 different elements from hydrogen to zinc. It consists of metals, non-metals as well as metalloids. Metalloids also there. Elements are basically classified into three types: metals, non-metals as well as metalloids. So metals means these are the elements which shows some peculiar properties. What are those peculiar properties? So it shows malleability and ductility. Malleability and ductility means it can be made into thin sheets and wires. That is malleability and ductility properties. They are a good conductor of heat and electricity. For all electronic appliances, we are using the metals for external and internal circuit because it is a good conductor of electricity as well as heat. Utensils are made up of metals, especially steel, stainless steel, copper can be used, even silver can be used because it is a good conductor of heat. That is one of the important properties of a metal. You take non-metals, these are the elements which it does not shows the properties of a metal, it shows a difference. With respect to malleability and ductility, it don't show malleability and ductility property. They are not good conductor of heat and electricity, and they are considered to be a non-metals. So we have another category of elements, they are said to be metalloids. What are metalloids? Metalloids are the elements in which it exhibits both the properties of a metal as well as non-metals. So germanium is a silicon, they are considered to be metalloids. Metal means gold, silver, copper, sodium, potassium, these are all metals. So non-metal means you take chlorine, fluorine, oxygen, nitrogen and also helium. They are all non-metals. This is how the elements are classified into metals, non-metals and metalloids. So why it is displayed means at least 1 to 30 elements should be known. Its a symbol atomic mass. So it is given atomic number of element 1, 2, 3, 4, 5, 6, 7. If I ask you what is atomic number of a nitrogen, you should say it's a 7. What is the mass, atomic mass? It is nitrogen, it is 14. What is the symbol? N. If you know the mass number, atomic number and symbol, it is very easy to learn chemistry. Okay. This is a symbolic representation. So A is represented as, it is a mass number, that is a Z, it is atomic number. So X is any element of your interest. This is how the atom can be represented. Now come to, I won't explain in detail about the structure of an atom, I will brief her. So if you take an atom, it is mainly made up of 3 components. Without knowing this, the next topic will be difficult to understand. That's why I am explaining in brief. See, structure of an atom. See, take any atom. See, this is one symbolic representation. Atom is made up of 3 components. One is proton, another is neutron, another is electron. Combining all these 3 in a definite manner, it is considered to be an atom. Atom of one element differs with respect to atom of other elements with respect to number of protons, neutrons and electrons. No other changes, just the number changes. As a result of change in the number, the structure of atom changes. As the structure of atom get changes, it shows different physical and chemical property with respect to other. Hence, this concept is very much important. Look here. While considering atomic number, I said atomic number for hydrogen is 1. You may ask, why sir it is 1? Why not 2? What is the criteria to give number 1, atomic number 1 for hydrogen? There is a theory behind it. See, this 1 represents the number of protons. Number of protons in that atom. If you take hydrogen atom, you find only one proton, or only one electron. So this species is said to be hydrogen. You take hydrogen from any source, hydrogen from any place. If you identify, if you split it, if you go through this hydrogen atom, you find only one hydrogen and one electron. This atom is considered to be hydrogen. Then 1. What is this? As I said, this superscript 1, it represents mass number. What is the meaning of a mass number? Mass number represents total number of protons and neutrons in the nucleus. This is the nucleus. So, one is a proton, another is neutron. So, how much protons and neutrons are there? This sum number is said to be mass number. So, here one have written. So, what it indicates? I said it is a sum of protons and a neutron. Proton is must for an atom, especially it is a major component of the nucleus. So 1 means it consists of one proton and no neutron. This is the only atom which is devoid of neutron. Neutron is present and neutron is absent in H11, that is hydrogen. So this is how atomic number and mass number can be given. In the same way, you take sodium. Take sodium. This is the symbol for sodium. It's a metal. Look here, atomic number is given 11. I am writing 11 here. Corresponding mass is given 23. Okay. Sodium, symbol and mass number is given 23. 22.98. This is important. I have written 23. Later it will be explained. Why I have not written 22.98? Why you got 22.98, 20.17? What is the reason? It will be explained in the next session. See what this number 11. What the 11 number represent? So this is subscript. This is nothing but atomic number. Atomic number is nothing but number of protons or electrons in the neutral atom. This 23 is mass number. What this mass number? It is the total number of protons and neutrons present in the nucleus. Combining these two, it gives the mass number. Already it is known to us, which is equal to 23. Proton number is known, 11. Neutron is not known 23. Therefore, number of neutron is 23 minus 11, which is equal to 12. How many protons are there? Total number of proton is equal to 12. So, number of protons can be calculated. Number of protons is equal to, which is nothing but A minus, this is Z, A minus Z formula. A means mass number, Z is atomic number. So with this we can calculate total number of protons. Now this topic is very much clear to you, how an atom can be represented symbolically and what are the significance of this number. Mass number and this is atomic number. Atomic number is given by the total number of protons or electrons in the neutral atom. Mass number is sum of protons and neutrons in the nucleus. These protons and neutrons are also said to be nucleon. These are the components of the nucleus. The entire mass of an atom is concentrated in the nucleus. Therefore, we are considering proton number, neutron number to calculate mass number. Mass of an electron is negligible. We are not considering electrons to calculate the mass number. This is how mass number and atomic number can be obtained. So atomic number, it represents the number of protons. Mass number represents sum of protons and neutrons. So with this topic I am concluding of portion of this chapter. There's some basic concepts of chemistry. Then the next part is different concept. We are explaining the concept of atomic mass, mass number, relative atomic mass, and also isotope concept, followed by moles and concentration terms. Let us meet in the next session. Thank you.